In this today's video, we are going to discuss all those important concepts of inorganic chemistry, and I'm going to tell you how much they have asked, and also you will get in clarity of what kind of questions can be asked. We are going to see the most important question you must solve before going to the examination. Okay, you must solve these questions to know your level in inorganic chemistry. Let me know in the comments similarly you want for physical and organic. Because I started with inorganic because this is in simple but mark giving chapters. So easy go chapters, you should get marks from this part. Okay, let's get started with the first one. Chemical bonding VSEPR theory, all are important. Bond angle, comparisons, dipole moment, and resonance structures. We can say almost three to two questions from this part alone for every year. And coordination compounds, CFSE, EAN rule, isomerism, everything is important. Naming the complex is asked many times in the paper. Okay, CFSE you can really expect. Then P block elements, oxoacids of sulfur, nitrogen, phosphorus, and hydrides. We are going to see some more questions on P block also. Trends, exceptions. If you need notes on inorganic, you can always download, where it is in our website. If you want, tell me the PDF link of inorganic, I'll send it to you, or you can check it out. Okay, then DNF block elements, particularly this point, KMNO4 and K2Cr2O7, color of the ions are super important. Oxidation states, and what kind of redox reaction happens here. Those questions are pretty much we are expecting this attempt. Then periodic table and periodicity, of course, the trends and exceptions. And in qualitative analysis, check out the flame test, confirmatory test. If you have less time, just check out these two. They can be asked several. It was asked several times. Then hydrogen bonding and intermolecular forces, the trends of boiling point, melting point, and what is stronger, weaker. That type of question we can expect. And oxidation state and redox concept, as I told you before. We can also expect this. And backbonding concept, Lewis acid concept, those are very important. Then noble gases and xenon compounds from 18 group elements. Along with that, hybridization, VSEPR. So these are the must-have checklist for your inorganic chemistry. Okay, so let's solve some questions on this. I'll be attaching the PDF of top 50 questions you must solve to know your level. And you can always download the top 100 questions of inorganic chemistry also, and to do more practice on it. Let's see the first question. Standard reduction potentials of zinc 2 plus to zinc and copper 2 plus to copper, silver to silver is given. Which of the following reactions will spontaneously occur? Okay, so this is more of a reduction potential. That's why I took it for the inorganic part. So if you see, what is the rule behind it? What is the basic principle behind this question? A spontaneous reduction occurs means when a metal with lower reduction potential, which means that is a stronger reducing agent, right? It reduces the metal from higher reduction potential. Okay. So first check one by one. First reaction says zinc 2 plus plus Fe gives zinc plus Fe 2 plus. If you see zinc and Fe, it's minus 0.44, this is minus 0.76, you will get minus 0.32 volts, right, which is non-spontaneous negative. Then copper with silver, if you do, then again you will get silver is plus 80 and copper is plus 0.34. 0.34 minus 0.80, you will get again the negative value of 0.46. Okay, that is not spontaneous. Then comes iron and zinc. To this combination, you will get plus 0.32, that is spontaneous. And option D, copper with iron, there also you will get a negative value, so which is not spontaneous. So simple rule, you can easily get marks from this one. Then, which halide of boron is the strongest Lewis acid? We know boride halides are Lewis acid. Okay, which is strongest among them? Why that is Lewis acid? That you know, right? That is having an empty orbital in it. Okay, and incomplete octet and so reasons. Among this, what do you think? What do you think which will be the strongest Lewis acid? You may think BF3 because BF is more electronegative. But what about in BF3, fluorine donates lone pair of electrons back to boron's empty orbital. And what about chlorine, bromine, and iodine? So if you see, strongest Lewis acid means which is having an empty orbital to accept the electrons. Right, Lewis acid concept is it should have an empty orbital to accept it. But in case of these, back bonding occurs. Right, because the halogens are having a lone pair in it. Among these halogens, which has a chance of giving the back bonding least? That is your concept. Okay, so if I have fluorine, then chlorine, bromine and iodine, this is the order will be followed. So iodine has the least back bonding, so boron empty orbital has the most available to the accept the electrons. Okay, so the order follows: iodine Bi3, that would be the strongest, then comes BBr3, BCl3 and BF3. Okay, then comes the next question. The structure of H2S2O7 pyrosulfuric acid or oleum contains what kind of bonds? Okay, so this is a structure based question. You have to know all those oxoacids of sulfur and phosphorus. I told you before. So can you answer to this question? So if you know the structure, you can answer to this one. You don't know, you can't. Okay, that's a straightforward question. You nothing more to think about it. Okay, and I can give you the pro tip, like it's more often, oleum is more often, think about 2 H2SO4 molecules are there. Okay, so think of in that kind of point of view, then you can easily answer this one. Let me know in the comments what is the answer to this one. Then the next one, the magnetic moment of the complex 2.83 bm. Which of the following could be the central metal atom? So nickel 2 plus, which is in square planar complex, and chromium 3 plus in octahedral complex, Fe 2 plus in high spin octahedral complex, and copper 2 plus in Na complex. Okay. So if you look at the Bohr magneton value, it should have a 2 unpaired electron. I told you before, if you have this Bohr magneton value, the first point, if you have 5 point something, 4 point something, 3 point something, the first number that would refer you, that would lead to your number of unpaired electron it has. Okay, so check out which will have the highest, I mean the corresponding unpaired electrons over here among this, then you are sorted. Okay, so if there is none of them matching with the value also, let me know. Then the next one, electrolytic refining of copper. The anode is impure copper containing silver, gold, iron and zinc as an impurity. Which metal will pass into the solution? Okay, you may think this is more of a metallurgy, ma'am. We don't have metallurgy in our syllabus, but it's more of an electrochemistry, right? So the simple technique to answer this type of question, even though you don't know the metallurgical concept, in electro-refining of copper, always think about which will take the cathode position, which will take the anode position. The impure copper is an anode. Impure one is anode. Any refining method, not only for copper. And cathode will be our pure. So we always heard about the word anode mud, right? So anode mud, it's like an impurity, like remember it like that. Okay, so this is the principle behind this question. So answer to this one is Fe and zinc pass into the solution, gold, silver remain as an anode mud. Because the metals are more reactive, the lower reduction potentials, then the copper dissolve into the solution as an ions, and iron and zinc has more reactive than the copper, so they get oxidized and go into the electrolyte. Okay. Then bond angle order of the following: ammonia, NF3, phosphine, PCl3, which is correct. So bond angles, all four are pyramidal with a lone pair. So here the bond angle is depend on the electronegativity of the central atom, right? That is what changing over here. So if you take ammonia, what is the bond angle? I have nitrogen. So nitrogen is small, hydrogen is not much electronegative. So the lone pair repulsion is strong, but bond pairs will stay close to each other. So the bond angle, that is 107 over here. Then if I consider NF3, fluorine is electronegative. So it will pull the bond pairs away from nitrogen. So the repulsion between bond pair and bond pair will be less in case of NF3. So what is the bond angle? That is 102. If you take phosphine bond angle is around 93. Why is it so? Because phosphorus is large and it almost uses the p orbitals for bonding. So it will have a very small bond angle deviation. Then I have PCl3. PCl3 is around 100, because I have chlorine as an electronegative atom and phosphorus is bigger, so which will give you this value. So you know the answer then. Ammonia, that is more, then comes NF3, then PCl3, then phosphine. Which of the following transition metal oxides are amphoteric? What is amphoteric? It's neither basic or acidic. It can react as both, right? It will react as both. Always remember these kind of oxides like amphoteric oxides, basic oxides, acidic oxides. Just remember one thing. Okay, so if I'm having lower oxidation state, okay, then that is basic oxide. Then if I have higher oxidation state, then that will be acidic oxide. Not lower, not higher, it's an intermediate oxidation state, means then that is amphoteric. Okay, here I have chromium O3, Cr2, O3, CrO, MnO7. So check out the oxidation states. Chromium here, that is in +2 oxidation state. And here that will become +3. Okay, +3, and in this part, this is CrO3. Wait, okay, sorry. CrO3, so which will have +6 oxidation state. Yeah, I didn't see the 3. Then Cr2O3, then that is +3, and CrO, that is in +2, O2 minus. Okay, then MnO7, it's supposed to be Mn2O7. Then that is in +7 oxidation state. This is the higher oxidation state. This is also higher oxidation state. Then what about +3 and +2? +2, that is in lower oxidation state, and +3 is an intermediate oxidation state of chromium. Okay, so this answer you might know already. Cr2O3 is an amphoteric, but for other type of oxides, if they have given you this type of question, then you can use this logic to solve the question. Then successive ionization enthalpies of an element are this much. The element belongs to which group? Here comes the understanding part, how we can proceed. So they have given the element's first ionization enthalpy value. Okay, always look for, if they have given the values, always look for sudden jump. Okay, so 577, 1817, 2745, and there is a sudden jump in 11,575. So it's roughly in 4 times, correct? So which means that Okay, so this means that the fourth electron removal is tougher. Okay, that is difficult. So E1, that is 577, E2 that is going successively, I mean gradually increasing, but there is a sudden jump. So among this, group 1, group 2, group 13 and group 3, which makes sense? So if you see group 13, what elements you can take? Nitrogen, let's say nitrogen. So nitrogen has 1s2, 2s2, 2p3. Right. So 3 electron removal, that is easier than the 4th electron removal. That is from 2s2 state. If you take phosphorus also, phosphorus is 15. So 1s2, 2s2, 2p6, 3s2, 3p3. Again the same thing. Right. So which makes answer to this question becomes true. Complex ML6 with octahedral symmetry, the CFSE for D4 low spin configuration is. Okay, so they have mentioned it's an octahedral symmetry and ML6 and D4 low spin configuration. So fill the values low spin. So which means that it's not going to pair up. Okay, so which will be low spin, more less number of unpaired electrons, and high spin, more number of unpaired electrons, right? So which will be T2G4 and EG0. So T2G4, what would be the CFSE now? So 4 into minus 0.4, which is minus 1.6. So that will become your answer. There is one pairing also, then that is not A, that will become D. In which of the following reactions is the oxidation state of nitrogen incorrectly identified? Okay, so you need to calculate all those nitrogen oxidation number and find out which is not correct. Okay, this you can easily solve. So again, I'm saying you these questions are must do. You should get more marks in these questions. I'll be attaching the PDF. So please do check out. Please try to solve all those 50 questions and download the 100 question PDF also to solve more questions. Let me know if you want a similar video for physical and organic chemistry too.